Hi everyone. Today we are going to see Kubernetes setup. As we discussed, like we will be using containerd as a runtime interface for your Kubernetes, right? And this setup will be done not on GCP, and this will be done on my on-premises, which means that on my local laptop I have installed Oracle VirtualBox, and then I am creating a virtual machines on top of this. On top of that, then I will be installing the Kubernetes, right? So which means that the virtual machines, nothing but instances which you technically call on cloud, we are creating on our local on premises. Okay, so in the in productions we use bare metal servers. On top of that, you create virtual machines using some kvm or any other hypervisor, and then we create a virtual machines. But here I'm using a software hypervisor which is called as Oracle VirtualBox, or you can use VMware Workstation in order to create this virtual machines. Okay, so let's go ahead and let's try to create two nodes. One is controller and one is compute. And this controller and compute will be having the same specifications like system resources. 6 GB RAM will be allocated to both the virtual machines, or let's say 4 6 like that. Okay, 2 core CPUs is mandatory. I have 8 core CPUs on my local, and I can use two core CPUs to my virtual machines. I will show you one VM, how to create and how to install the operating system in Oracle VirtualBox, and what are the things we need to follow. Later on, another VM, I will be pause the video. That will be once it is pinned up, then we will log in and then we'll do the Kubernetes setup, right? So once you log in, when you install this Oracle VirtualBox for the first time, and if you want to install it, just you can go here, search for Oracle VirtualBox. Okay, you can go to the downloads and you can install the latest one. If your base operating system is Windows, try to click on this. If it is Mac, click on this. If it is Linux distribution, again you can click on this, and you need to install this particular extension package as well. This is common for all the platforms. It is specific to Oracle VirtualBox, so that's the reason it is not it is common for all the platforms. Okay, this is for every platform. It will have a different compiled files actually. Okay, so just download based on your operating system and down. I'm using Windows, so I just downloaded this particular exe file and I installed. Okay, so once that is done, it looks like this. You will not have this VM as well. Okay, so it completely looks empty, and this is how it looks for you. Okay, so you need to go to the option called new. Okay, give some name. I'll be giving control plane. Okay, so that I can identify. Linux is your type of operating system, and what version. I'm using Ubuntu, so I'll be selecting that particular icon. Is that Ubuntu? Yeah, 64-bit, right? So I'll be assigning subs. You can see here I have 20 GB of RAM on my base machine, so I can allocate up to. I will just allocate only 4 GB to this control plane, right? It's enough. And create a virtual hard disk. See, whatever you create right now, it will be a virtual RAM, virtual CPU, virtual hard disk, and all. Okay, create, and then don't modify any option, just next. Dynamic allocation and fixed size. By default it will be enabled with the dynamic allocation. If it is not enabled, go with the dynamic allocation. So dynamic allocation in the sense, whatever the disk has been assigned to you, the virtual disk, you will not use the entire disk right away. You will use how much you want for your operating system right now. It will use that amount of disk space, and based on the need it will increase dynamically, and it will go to the maximum limit that we have allocated. Where I will allocate that, you can go to the next. Here it is maximum 10 GB, right? I can allocate up to, let's say for this session I will be allocating only 30 GB, or let's say 60 GB. That's fine. Okay, and then create. Now this virtual machine is created. Okay, but we haven't installed any operating system. Okay, that's one thing you have to remember. Now let me create another one, that is for compute. Compute plane 1. Same naming convention what I followed in GCP. When you are using Docker, I did the same thing right now. Okay, select Linux type and Ubuntu as your operating system. Where is this Ubuntu? Depend Ubuntu 64-bit. Next, allocate something around 4 or 5 GB or 6 GB. In my case, I will just allocate. Next, create VDI extension and then dynamic allocation, and here I will be just giving some 60 GB. It's enough. So create. Now these two virtual machines are created. Okay, these two virtual machines are created. I will make this as a group. Okay, group in the sense I will create a group and I will give some name to this group, like let's say, okay, this is my group. Okay, I'll give some name, rename the group. Let's say I will be installing 1.21.4 Kubernetes version. Okay, I gave that name, which means that it will be separated, segregated. That's it. Okay, so now these are the two VMs which I have created. I'll show you the installation of operating system in one. You can follow the same for the next operating system. So what are our system specifications? Okay, you gave 4 GB RAM. What about CPU and other specifications, networking and all? Let's see. Go to the settings here, or you can right click and you can go to the settings from here as well. Okay, there are two ways to open your settings of this VM. So click on settings and then go to the first system, go to the process, and here you can see I have 8 core CPUs. In that I will be allocating 2 core, which you already know that minimum number of core CPUs that you have to allocate for a node which you want to form a Kubernetes cluster, it should be 2. Okay, and then storage, this is fine. Okay, storage, you have to select the operating system ISO, right, to get booted. So here you can click on empty, just click on this disk. I did so many times, but you have to download this Ubuntu 20.04 live server ISO. I'll be giving in the description how to download it. You can just download from there. Okay, so once it is selected here, if in your case you need to choose the disk file and you need to go to the downloads location and you have to select that, you can see here it is in my downloads. Okay, after that, networking, I don't want to use NAT. Why? Because if I use NAT, I cannot do an SSH from my base machine. Okay, I will get the internet connection, but the problem is I cannot do an SSH to this particular virtual machine, right? So I'll be using bridge. So bridge in the sense what? How you are getting an IP address from your router. See, I'm getting an IP address from my router. If you want, let me show CMD command prompt, and if I show you IP config, sorry, you can see here this is my IP address of my base machine which I'm getting from my router. If you want a similar IP address, like the IP address that should be assigned from the router, okay, you need to select bridge adapter. Automatically it will select the wireless connection, like whatever the network I'm using automatically, which means that now I will get an IP address from the router. The advantage is that I will be able to connect to the internet. How my mobile, when I connect through Wi-Fi to the router, how I get an internet connection, similar to that. Okay, and I will be able to communicate from my base machine to virtual machine, and another other virtual machines also can communicate to my VM as well. Okay, so all the conditions are satisfied for me with this bridge network. Okay, promiscuous mode, you need to go to advanced. Okay, promiscuous mode should be set to allow all. Okay, and then click on OK. Once this is done, let's try to boot this. Double click on this. Okay, simple. Okay, here it is. You can see on my second screen actually. You can see it's coming up. So what I need to do, I need to install the operating system on this particular VM. So I assigned the ISO. So ISO will give me the page in order to proceed further for installing the ISO. Same steps you have to follow for your compute node as well. Whatever I do, okay, so you have to follow the same. For controller, I will give 192.168.1.90, and for compute, I will give 192.168.1.91. Okay, so that is my series actually, IP address series. In that I'm giving 90 and 91. Let's wait. It takes some time actually. Okay. So now the first thing what you get is nothing but it will ask you to select the language which you want to use in order to interact while installing the operating system. So comfortable with English, so proceed with that. And what should be your keyboard language, which means that once your operating system has been installed, what language you want to use in order to communicate to your operating system. So from the terminal, I want to use English language to communicate. So done. Here you can see automatically I got some IP address. Okay, so that is like a DHCP. Okay, continue without networking. So here let's try to edit the IP address IPv4, or instead of automatic I have to do it manually. So I want to allocate the IP address. Okay, so manually in the sense what should be the subnet is like 255.255.255.0. It is slash 24. That's a reason. Or okay, sorry, you need to give with IP address, so it should be something like 192.168.1.90/24. Okay, so this is how it is. 192.168.1.90 must be bits. Okay, just a second. Name servers, I could say this. What happened? This is what. Okay, 168 1 dot. Okay, so what is my base mission? It's 1 series, right? So I'm comfortable with this. So 1 dot. I'll be going with 90. Okay, slash 24, and then the address is okay. So what should be your address? So sorry, my bad again. The problem is here I need to go slash 0/24. Okay, that is your network. Okay, what should be your IP address? 192.168.1.90. So my bad, I did some mistake. And the gateway, whatever the gateway you see on your base mission, the same gateway. Okay, so 192.168.1.1. Obviously the first IP address will be your gateway. Okay, if not you can change. Name servers, I want to use Google name servers. Okay, for now. So comma 8.8.4.4. These are the public Google name servers. Save. I'm okay with this. Save. Okay, so it is trying to apply. Done. It says like not connected. Now it is connected. Okay, so done. Continue. No proxy servers. Enter. Continue. Again enter. Again here I'm okay with this disk partition because it will use LVM partition. It will use the entire disk. I'm okay with this. So use a tab and go to the done. Okay, option and just press enter. This is the partition how it makes automatically by your ISO, which will do the partition. So I'm okay with this. So done. Do you want to continue? Yes. So set your name, set some host name, create some user with some password. Why? Because Ubuntu, once the operating system is installed, it doesn't allow you directly to log into the root user and with some password. Okay, it doesn't allow you to set a password for the root user itself. So how will you log in? So that's the reason we will create some user with sudo user, and that's how you can shift to the root user later on. Okay, so this is like I will give my name, and the server name is control plane. Okay, control plane node. control plane node. Okay, and then what name I want to use, test user, that's it. Okay, and then test123 is the password so that I can remember a bit easy. Done. Install SSH server. Why? Because if you want to do an SSH communication to your virtual machine, this package has to be installed. Okay, so select that by using a space bar. Okay, and then use tab, go to the done and press enter. Now don't install anything here, just go to the done with the tab space, tab, and then press enter. Now operating system is getting installed into your disk. Okay, virtual disk it is. So I'll be doing the same thing on this virtual machine as well. Okay, this virtual machine also I will do the same thing, but I will pause the video for now. Okay, so here I'm assigning my host name as compute plane 1. Okay, so compute plane 1. Okay, so just to update that, just an update, you can see on the control plane, right? You got two options, view full log or cancel update and reboot. So you can select this particular option and you can cancel the update which is happening in the background, and you can reboot your system, which means that operating system will get loaded from your disk. If you want to wait until the update is done, don't do anything, so automatically it will start with it will reboot and it will load your operating system from the disk itself. Okay, so I'll be waiting until that particular task is done, then I will just log into my system with my username password which I have created. Okay, so let's wait. It takes some time, so I will be pausing the video once again. So now we can see here we got reboot now, so let's reboot. Okay, then here also you will see something like reboot now, so it's cancelled. Okay, here I didn't got a reboot now. Here this is what's done, just press enter. Okay, so it will load your operating system from your disk, the virtual disk which we have created, right? 30 GB or 40 GB or 60 GB which we have allocated, I guess 60 GB, so that will get assigned. Here installation is complete actually, so we can just cancel and we can reboot. Here I got a reboot, which means that installation was done much faster than the previous node. Okay, so it is loading your operating system, all the services which are needed to start your operating system. Then you will get a login prompt. This is called as console access. Okay, your virtual machine console access, or technically if you are a bare metal server, it is called as ILO access or ID rack access, right? That's how we call. But here this is itself is my direct access, so this is called as console. Okay, remember these terms, that might be useful to understand when you're having some discussion with some engineers or someone. Okay, right? So now I got a login prompt, so here I need to give my username password. So don't forget about this, what you're getting. So it's like login screen, you'll get some things which are going in the background. Okay, here I need to give my username password which I have created while installing the operating system, right? So test user, and the password is test123. If that is authenticated successfully, then you can see I logged in successfully. Okay, then I can shift to the root user. Now after giving the password successfully, you can see I shifted to the root user. Now I can set a password for the root user now. Okay, so test123 again and test123. So password was updated successfully. Now if you give something like control D and again control D, again you will get a login screen. Okay, so once you got a login screen, if I give root test123, I will be able to log in as root successfully. Okay, and look at your IP address. You got your IP address what you have assigned. Let's check the configuration file for this network. Okay, so net plan. Okay, open this configuration file. Yeah, this seems to be fine. DHCP is disabled. Okay, so these are fine. Done. So I'm okay with this. Means every time when I reboot my system, I get the same IP address. We will do the reboot now. Before doing that reboot, as I told you in the GCP installation as well, we have installed Kubernetes on GCP. When we created an instance, the first command when you spin up or you start your virtual machine of Ubuntu, first command is nothing but update your apt database. Okay, so that it will communicate to the repositories what you have used or whatever is available. Okay, so I think there is no internet connection. Let's see, or let's try to solve the problem if that is the case. Yeah, so temporarily not available. Let me show my base machine. Just a second. D. Let me cross verify with the IP address what I have. IP config. Okay, you can see 192.168.1.0 series 1.gateway is fine. Now I was not able to communicate. So here IP address seems to be okay. Let's check the DNS entries. So resolve.conf. Here is the issue. Okay, so I need to remove this and I need to add something like name server. Okay, 8.8.8 and then name server 8.8.4.4. Okay, save this and come out. Now if I execute ping, let me execute update. Okay, if that works, I was able to communicate to the internet. So you can see here control pin is also up. Just enter. Here again it is the same issue. Let me cross check what happened exactly. Again it's the same issue. IP route was added successfully. Gateway was fine. Everything is fine. /etc result.conf. Net stand. Net plan. Apply. Okay. Configuration again it is getting updated now. So let's do one thing. /etc net plan apply. Here I will do like BHCP. Okay, BHCP4 false. Okay, name server, this is fine. Search, I don't want this. This is fine, this is fine. Gateway subnet, everything is fine. Okay, this is fine. So net plan apply. See the IP address, that's fine. Ping google.com. Doesn't work. Resolve CTL status. Okay, unknown operation. Okay, just a second. So current scopes DNS. Okay, this is fine. Name server 8.8.8. Name server 8.8.4.4. Reset this file and come on. Still have this problem. Let me try to resolve this. Simple thing. Let me try to do a reboot if it is possible. I will see if that makes any sense. Init space 6 in the sense it will reboot. Let me see if my network configurations get updated. Init 6 in the sense it will reboot. Init 0 in the sense it will shut down. Okay. Here what happened? I got a login prompt or not? Loading essential drivers. It's under process. Let's wait. Let me pause until this login prompt was shown, right? You can see after reboot the issue has been solved. I was able to ping. Computer node is done. Let's log into the control plane. Test user test 123. Okay, I logged in. Shift to the root user and then assign the password to the root user. the same password. Okay, since it is my mission and it is running on my local network, so that's fine. Now let me try to ping google.com if this works. Yeah, so able to communicate to the internet. The first command which we have to run, as I told you, apt update command on Ubuntu machines. Here also apt update, and after this we have to upgrade your packages, because the ISO when it's created, the packages might have some version. Now the packages might have a different latest version, right? So I want to update all the packages. Dist upgrade which we used to execute, right? Same. Enter. You can see it is done on the control plane. It is going on the compute apt dist upgrade, and then enter Y, or you can just press enter. Automatically it is accepted and it is going downloading and it is getting installed. Okay, it takes few minutes. After this, as you all know, we have to use container D, right, as a container runtime interface. So now no need to follow the document of Kubernetes, sorry, Docker. Actually we can follow, but yeah, we have this documentation. You can go to this repository, you can fork it and you can just use it. You can go to this Kubernetes latest manifest, go to Kubernetes, then go to Kubernetes architecture and installation. That is the first topic that we start in this session, Kubernetes session. And then we have to use container D. For Docker, we have already seen that step-by-step process how to do, and the video was uploaded as well. You can search for that, or you can, I will give you in the description. And now you can look at this particular container D. So here it is already written. Let me explain about this once the basic setup is done. Okay, let's do that first. So it is going on. What is the next thing we have to do? We have to like all the things are done, both the VMs will able to communicate, that is for sure. And the next thing which I need to do is nothing but I need to do an SSH to this VMs from outside. Okay, will that be allowed, or do I need to do any configuration changes? So let's see. And one more thing is we have to disable the swap memory. So let's do that first, swap memory disabling, and then we will verify the SSH communication from my local machine. From my base machine, I will try to do an SSH. So on this note, this is done, right? So if you see, if you execute free space -h command, you can see swap memory is enabled. Okay. In GCP, when you are using that image, Ubuntu image, it's not enabled by default. Okay. But here, if I need to disable temporary, if you want to disable swap off -a, swap memory is disabled. But if you reboot your system, again it will get enabled. So I want to do it permanently. So fs tab. Just comment out this line, okay, and then save this and come. So since we did upgrade and all, right, so let us try to reboot the system. Okay, so init space 6, because my kernel also got upgraded, so that's the reason. So let me show you, get a login prompt. On this machine also I will do the same thing. I will disable the swap memory temporarily, and then I will do permanently, because since I will reboot the system, right? So once you reboot, since it is not enabled in the configuration file, your swap memory will not get enabled. Okay. Let me log in with root test 1 2 3. Okay, you can see swap memory is enabled or not. Just see, it is disabled. Okay, we already did that, right? So your mission is ready now to go forward and install containerd and Kubernetes and form the Kubernetes cluster. So this node also should be done. Let's wait. Then I will show you the SSH communication. Is almost done. You can see initramfs generating this image. It's like updating your initramfs. So the RAM got upgraded from 64 to 84. Yeah, 65. Sorry. Patch version. So I have to reboot. Oh, sorry. This is done. So what we can do now? So disable the swap memory. So you can see here it's enabled. So disable it permanently. FS tab, file system tab. Comment out this line and just save it and reboot the done. So let us try to do an SSH to this VMs 90 and 91, right? Am I true? Let's verify the IP address 90 and here it is 91, which I already know. So here I am using MobiXterm in order to log in. So 90, 91, right? Session SSH IP address is 192.168.1.90. Username is root, and then let's try to communicate. OK. Here it is prompting for the password. So test123, which means that it is reached to the VM. Now it is asking you to give the password. I gave test123. It's not working. So what could be the reason? My password is correct. See, test123 was working from the console. It is working from here, right? If I want the proof, okay, root test123. You can see it's working from here. But why not from remote location? Means from remote mission, why you're not able to do an SSH for the root user? Okay, okay, is it blocking only the root user? Let's try to see. Let's try to communicate with test user as well. 90 test user. Okay, then test123 is the password. So with the test user, it is allowed. So direct root access from the remote location is not allowed. Okay, so just you have to remember, if you want a root access that should be enabled, simple thing, simple logic. Okay, I will do it from here. Okay, or else let's sign out. Okay, so I'll do it from the console itself. Open the configuration file. You installed OpenSSH server package, right? If you have remembered, I enabled one particular package that should get installed, OpenSSH server. So that particular package will have a configuration file called sshd underscore config. Don't open ssh underscore config. That is a client package configuration file. This is a server package configuration file. Open this file. Go to this line called permit root login. Okay, set to yes. Go to the insert mode, set it this and save and come out. Okay, once you do this, systemctl restart shd. Done. Now let's verify. Sorry, this 192.168 1.90 root and then click on OK. So now again I got a prompt, login prompt. So test 123. Now you are successfully logged in. Okay, since that parameter by default will get disabled, so you cannot do an SSH to the root user from remote location. Okay, so do remember this point. Let's go to the compute. I think compute also will have the same problem. Since you already know it, let's enable. You can do it, you can do the changes of the SSH configuration file only from the root user. Okay, so /etc ssh shd underscore config. Go to the line permit root login and then set it to yes. Save and come out. Systemctl restart shd. Sorry. Yeah. Now open another terminal. SSH 192.168 1.91 root. Okay. For the password, give the password properly. Save. So done. So my next VM I was able to log in successfully. Okay, so both the missions I was able to do an SSH from remote. Okay, now I can go ahead, I can use multi-execution. Why? Because until some particular task I can both the nodes should have the same packages. What are those? Let us see. I need to install containerd, right? So to install containerd, both the nodes should have containerd. So how I can get it? You can just execute these commands. Okay, same commands what you execute for your Docker, as actually we can use that. Okay, it is similar. We are using a Docker repository to download and install this containerd.io. Okay, so same commands, just copy paste this, copy paste on both the nodes. Okay. Okay, multi-execution, right? So enter. You can execute on multi-paste. Okay, consider this time. Okay, you can see if I give Control C, or you can see both the nodes are executing the same at a time. Sometimes there would be a problem, but yes, you have to keep an eye on this. After this, you can follow the Docker documentation actually. Okay, to follow this, actually you can use a Docker documentation. What you can do, you can just open. I'll tell you what need to be done. To install containerd package, we are using this. So execute this command on both the nodes, multi paste. Okay, enter. So on both the nodes, it is getting installed. Next, this command. Copy this. Again, multi execution. Enter. Okay, clear the screen. Next one is execute this command. Multi execution. Okay. Okay. Done. Then we have to execute update command. As you all know, whenever you create a new repository, we need to run update command. Okay, so we have downloaded the ZPC key to communicate to the Docker repository, and we have created a Docker repository under /etc apt resource.d. We have this Docker source file. Okay, now download the package. So to install the package, we have to use apt get install containerd.io. No more Docker. Okay, so apt install -y, I'm accepting that container d dot io, yeah. So it will install the latest version, right? So your container runtime interface was done successfully. Next, what we have to do? So I will give this particular documentation. I have written here the same comments. Additionally, we have to configure the container D. To do that, you have to follow this document. Okay, this is in the GitHub. You can open the file and just you can follow. So it is done. Clear the screen. Now copy this command. Create one directory under /etc for container D. So multi-execution done. After that, execute this command to create a base configuration file for your config container D. Oh, sorry, it's re-executing. It's not copied. Okay, okay, done. After this, we have to restart our container D. Okay, so that is what we have to do because you did some changes in the configuration file. Okay, so that's the reason. Let's verify the status. It's running or not. On both the nodes at a time, you can see. Okay, it's running successfully, which means that our task related to container D was ran successfully. Okay, we are okay now. Okay, so let's go ahead. Now we need to install the Kubernetes packages. Okay, to install this particular packages, you can follow the same documentation. This is, I guess it is already done, but let us re-execute this once again. Nothing will happen, right? It doesn't cost you anything. Done. So you already know the firewall is not enabled on Ubuntu by default in my case, so I'm okay. Runtime interface, we are using container D right now. Okay, and now let's install the packages. So install this. Hope this will be done. Okay, now download the ZPZ key for Kubernetes repository. After this, you know that you have to create a repository for Kubernetes. Again, multi-execution. Now update. Same, I will be using a 1-bit down one latest release. Actually, latest release is 1.22. I'll be using 1.21. Okay, 21 latest patch. So I guess I can copy this particular option instead of executing this, right? What I can do, I can go to my documentation of this. I can go to this Docker. I did last time, right? So I'll be using the same command. Okay, you can see here. I installed this. This is the last version, patch version of your 1.21. Okay, so I'll be using that. What is that? Okay, there it is. No? So your Kubernetes packages are getting installed. Okay, you can get it from here. I'll update the document as well. No need to worry. Okay, but be careful. Every time, no, don't execute that. See what is your latest version of Kubernetes. Don't use the latest one because there are some complexities. Yes, we can use it. Maybe this 1.22 is having some complexity. Okay, we will discuss this at the end. Okay, why we are using container D, because if I tell now, you will get confused. So now we are using container D as a runtime interface for your Kubernetes packages are getting installed. After installed, you need to execute this command in order to hold the packages from auto upgrade. Okay, so this command, what it will do, it will hold the packages, this particular packages, 3 packages from auto upgrade. Okay, until unless you unlock that, unhold that particular packages, then only you can upgrade. So which is better for me, so that my Kubernetes cluster will not get automatic upgraded. Okay, so just hold it. Done, right? So your Kubernetes setup is done successfully. Now we can exit multi-execution mode. Why? Because from now only one node should get bootstrap, that is control plane node first, and then you need to join this particular compute plane to the control plane. Okay, so how to do that first? So you already know that this particular command you have to execute. In my case, I'm using 1.90 as I already told. So here you have to remember one thing. If you remember the Calico, if you directly execute this particular commands, it will use this particular pod CIDR. But 192.168 series I'm already using for my base machine. You can see here. So I don't want to disturb my base operating system network with my pod network. So I want to change this. Okay, first you have to execute this particular command with your own CIDR what you want. That particular CIDR you have to update to your Calico saying that I want to use this particular CIDR. If you don't specify that, you will bootstrap with one CIDR and your Calico will try to use another CIDR, which will mess up. Okay, so that's the reason. In GCP we did directly because GCP doesn't have this network on the base. Okay, so that's the reason. But here I have this particular network on my base machine. So I don't want to get conflict with the base machine network with my pod network. Okay, so what I have to do, execute the same command. You know pod CID advertise address and all, right? We used to do. Let's do once again. Kubeadm. What's the command? Kubeadm init --- API server and address. Okay, is equal to 192.168.1.90. Okay, and the pod CIDR, right? What is the pod CIDR? Let's take from here. Instead of this, we have to use, what is that? I will be using 10.244. Okay, generally I used to do like that. So that's the reason I will go with my CIDR. You can use whatever you want, a private CIDR from class A, B, or C. This is class A. Okay, in GCP we used class C. Enter. So it is going on. So it is same. It is downloading the images, then config, kube configs for the services, and then it will certificates, and then it will create a it will download the manifest files for your components, control plane components and compute plane components, and then it will form your cluster. This is what happens in the background. So these are called like tools which are used to spin up your clusters. Always in any cluster you see, first we will bootstrap only first node, one node, then all other nodes will get joined one by one based on the commands what you execute. Any cluster you take, any scenario, any real-time cluster, even Docker Swarm does the same thing. It is taking some time. Let's split. It depends upon network speed. In GCP it doesn't take much time. Why? Because the network will be much faster than my local network. So it's going on. Let's wait. It's almost done. Okay, now you can say it is successful. Now as you did on the another, you have to create this particular, you have to execute these three commands. Okay, one to create a directory, copy the admin config file to this particular file under your home directory, and then change the ownership. That's it. So let's execute this one by one. You can just copy paste. Actually you can say it's copy paste. All the three commands got executed. After this we have to deploy your Calico. So here, in order to deploy the Calico, I will not execute as it is. Instead of that, I will download the YAML files. I will do the modification. First YAML Tiger operator, nothing to do actually, but still I will download it. Okay, I will download this, and again I will download this particular Calico resources.yaml file. This is the file where you will update your pod CIDR. Okay, duplicate command is to download the file. Okay, now these two files are downloaded, right? So let us open custom resource.yaml. Here you have to update your CIDR. See, if you, as it is, if you execute, it will try to pick this particular CIDR, which will get conflict. Okay, it got updated, right? Save this and come out. Now apply this YAML files, both the YAML files. So kubectl apply -f custom and then -f, sorry, Tigeri operator first, and then your custom resource. Done. After this was done, if you recall, after executed successfully, this is the command, network is done, right? This is the last command that you have to execute on the node which you want to join as a worker to your cluster. So this is my worker node. Okay, so I have to execute this command on this node. This will be done. Let's wait. Once this is done, it will tell you like, okay, this node was joined successfully. Keep execute kubectl get nodes on the control plane node. You can see. Okay, so go to the control plane node, kubectl get nodes. Done. Not ready as of now, which means that your pods are in still, it's under creation process. So let's see. What are the pods? -f and all -name spaces. All your Kubernetes related components, network related components should come up. You can see they are under creation process. So that's the reason your nodes are not yet ready. Okay. So always keep this particular point in mind. Okay. I will copy this actually. This might be helpful for us. Okay. Anyway, I'll just copy paste this details to verify whether the nodes are ready or not. Let wait until these are done, and then you can do it. Doesn't take much time actually. It depends. Okay, it should download the image, then create a container. It depends upon each and every pod. Once that is done, we are successfully deployed our Kubernetes cluster. Okay, with this we will be done with this particular session. Hoping this, yeah, it's under creation. It's moving on. Let's wait. Documentation, should I need to update anything? Let's see. Okay, all updated, this is done, this is done. I clearly explained that. Okay, after that what you have to do, everything on the control plane node, just execute this. Okay, this is what I have to do. If you want to launch your pods on the control plane as well, then you have to execute this command. Okay, this you will come to know in scheduling, Kubernetes scheduling actually. But right now if you want, okay, you have only one compute node, I want two nodes at least to launch applications, then you can enable this particular master node as well to launch the pods. Okay, it is optional. Okay, not mandatory. I clearly written this. By default, control node will not able to launch the pods. So to enable execute below command. Simple. Let's wait. It's almost done. Only these two containers are pending. They are under creation process. All other containers are almost done. Okay, one node is left. One pod, sorry. One pod is left. By this time, I think the node should be on almost ready. Yeah, these nodes are ready right now. You can see it's running. See, this could be some cases. This Calico node, it is showing you as running. The pod is running, but the container is not yet ready. So you have to observe this as well. So let's wait. Let's wait. Now you can see it's almost. Let's wait. Let's wait. Now we can see Calico node is done. It is now running. Okay. After that only your Calico API server is getting created. Okay. Till now you haven't seen this pod, right? This pod will be available only after Calico node was done. All the two pods have been done successfully. One will be running on control plane and one will be running on compute plane. Okay. I think this also should be done. Yeah. Now all are ready. Now you can say like your nodes are ready right now. Okay. You have to verify that as well. Okay, don't say that this particular status is ready, which means that your all the pods are running. Actually true, but still you have to verify. Okay, This is how it is. So this is your master node. You can see the role which was assigned automatically by your KubeADM. Nothing was added. It is nothing but your compute. Okay. By this we can tell also which is compute and which is controller. Okay. So with this we are done with the Kubernetes setup with container D as a runtime interface. Now let's understand why we have to go for container D. Okay. So if you try to look at this particular diagram, this is what the default architecture, how it looks, how we are able to use Docker for our Kubernetes. So kubelet will contact to Docker using Docker shim. That is a plugin which kubelet will use this particular Docker shim plugin which is developed by Kubernetes, and that will be used in order to pass information to the Docker, and Docker will pass information to the container D, and container D will use a runc in order to create a containers. Okay, so this is such a long process in order to like create some particular resource. So that's the reason Kubernetes have thought that why can't we do like this? Without using Docker, can't we directly communicate to the container D? So that's how they have implemented a plugin called CRI-container D. Okay, that plugin was implemented by Kubernetes, and that is an interface which is used by your container runtime interface called kubelet in order to pass information to the container D. So that was done in the release of container D 1.0. Okay, so kubelet will pass information to the container D with the help of CRI container D, that particular plugin. So will pass information to the container D, and container D will use runc to create a containers. Now after container D 2.0 was released, what they have done, your container D itself is providing you a CRI plugin. Okay, so the burden has been reduced by your kubelet, where kubelet can directly talk to your container D with this inbuilt plugin, and that's how it can communicate. So much faster creation of the resources, right? Fetching the resource details and creating the resources will be much faster compared to your traditional Docker as a container runtime interface. So in the container D 2.0, you will see this is the architecture, how it looks for your Kubernetes. Okay, right now what we are using. Okay, so this is all about that particular architecture, why we are using containerd instead of Docker as a container runtime interface to avoid the latency. That is a main intention. When you have large components that getting installed, maybe for few applications you may not observe, but when you keep on growing, your infrastructure is going on, when you are installing so many applications, that will come into picture. Okay, so for that reason, so that's the reason Kubernetes has deprecated this particular Docker support from 1.22. Okay. So then next point is, yeah, the last point which I want to talk is, yeah. So since you are using container D, if you are using Docker, okay, I can use a Docker CLI commands in order to check the container details. Now I don't have Docker. How I can communicate to my container D? For that we have we have CRI CTL. Okay, like CRI-CTL, which will be used in order to communicate to the Docker. So now if you see, CRI-CTL will be there. Okay, so now if I execute CRI-CTL images or ps command, it will not able to communicate. It doesn't know how to reach to the container D. So we have to tell to CRI-CTL, okay, this particular utility. So what is that? We have to create a file under /etc crictl.yaml. This debug actually it's not needed. You can just ignore actually. This debug I will remove. This will give you unnecessary information. So your CRI-CTL is trying to communicate to your container D using this particular socket. Okay, because socket is a main, right, which you want to like send some API calls. Now if you execute, you can see you got your pod related information. If you want your images, now this will be our tool in order to communicate to the container D. Okay, that's how it is. So you can do the same thing on your node as well. Why? Because the images what are present on this node will be different on this node. Okay, so oh, sorry, remove this. Okay, If you add also, nothing will happen. It will show you unnecessary logs. CRACTL. Done. That's it. Okay, if you want to troubleshoot and if you want to see the logs of the container, why your pod is not up and all, this will be helpful for you. Okay, what are the images you have and all. That's it. Okay, because you don't have Docker, right? Docker ps command if I execute, it doesn't because you don't have it. Okay, this is how it is. So with this, we have completed our Kubernetes cluster installation with containerd as runtime interface. Okay, thank you. Thank you for this particular session.